In the previous video, we had learned about ionization enthalpy. In this one, we are going to be learning about electron gain enthalpy. Now, when an electron is added to a neutral atom, energy is released, and this is called as electron gain enthalpy. It is represented as delta EGH, and it generally is measured in kilojoules per mole. And so basically, it is considered as the enthalpy change when an electron is getting added. And due to this, it can be either an exothermic process or an endothermic process. Now, in the next few slides, we'll be looking at various values of the electron gain enthalpy. And the negative sign in few of those values means that energy is released when the electron is added to the atom. Now, to make things clearer, okay, basically the negative sign in front of electron gain enthalpy means that it is easier for us to add that electron into the atom. So your halogen elements or the elements of the halogen group will have a negative sign in front of the electron gain enthalpy. This is because it is easy for them to accept electrons. On the other hand, your alkaline metals and alkaline earth metals don't have a tendency to add electrons to it. So their value of electron gain enthalpy will be relatively less. Now, there are various factors that affect the electron gain enthalpy. The first is the size. Now, the size of the atom, if there is an increase in the distance between the nucleus and the incoming electron, there'll be obviously less attraction between the two. And so the electron gain enthalpy will be less negative with increase in size. So electron gain enthalpy is less negative as the size of the atom increases. Second is the charge of the nucleus. Obviously, because the nuclear charge, if there is a higher nuclear charge, it means the attraction of the nucleus to the incoming electron will be high. So the electron gain enthalpy will be more negative. The third is the electronic configuration. Now, if you have stable, again, you have the half-filled and the completely filled orbitals are going to be more stable than the others. And so they have a less tendency to accept an electron compared to the others. And so their electron gain enthalpies are less negative. So the first is size. Bigger atoms means the nuclear charge will not be easily affecting the incoming electron. So they will have less negative electron gain enthalpy. The charge of the nucleus, if there is a high nuclear charge, that nuclear charge will be able to pull in the electrons. And so such atoms will have a more negative electron gain enthalpy. Electronic arrangement, again, over here, half-filled and completely filled orbitals are completely satisfied, and they don't want electrons added to them. So they're reluctant. So they will have a less negative electron gain enthalpy. Now, look at this particular thing that we have here, the table we have here. So I mean, we've excluded the elements of the D block and the second group of the periodic table. So we're considering group 1, 16, 17, and group 0. Now, as we go across the period, we know that the size of the atom is going to decrease. So the negative sign, so the electron gain enthalpy will become more negative as we go from left to right. But this is excluding our noble gases or inert gases, because all of their electron gain enthalpies will be positive. And this is because they are quite satisfied with their electronic configuration. And if a new electron has to be added to the next step. And that is not okay with them. Okay, so, and as we go down the group, the size of the atom is going to increase. or the sorry, I'm so sorry, the size of the atom will increase because the atomic radius is increasing as we go down the group. And because of that, the electron gain enthalpy is becoming less negative. Okay, so if you see, lithium is going to be the smallest in this group, so it has the most negative electron gain enthalpy compared to the other elements of group 1, than sodium, potassium, rubidium, and cesium. So as we go down the group, the electron gain enthalpy, the negative sign in front, the value of the electron gain enthalpy is becoming relatively less negative or more positive. Okay, so across the period, again, if you notice, all of this boils down to the size of the element. Sorry, size of the atom. Now, there are few things that we need to observe. First one, halogens have the highest negative electron gain enthalpy. Now, this is because all these elements need just one more electron to gain the stable electronic configuration. And so they are, it's quite easy for us to add an electron to halogens. And so their electron gain enthalpy is highly negative in nature. Next, electron gain enthalpy values of noble gases are positive. And this is because of their stable electronic configuration. So they don't want any more electrons to get added to them. They're quite satisfied. So the electron gain enthalpy is actually positive. They don't need an electron. Next, notice the values of I don't think those elements are in this group, but generally, the value of electron gain enthalpy for elements which like beryllium, magnesium, nitrogen, and phosphorus are going to be higher because of their half-filled and completely filled electron or orbitals. This is the same thing that had happened with ionization enthalpy. Ionization enthalpy of beryllium and nitrogen was higher than the adjacent element. Similarly, the electron gain enthalpy for these elements, beryllium, magnesium, nitrogen, phosphorus, is almost zero because of their half-filled and the completely filled orbitals. Now, if you notice over here, fluorine and chlorine, fluorine has a less negative electron gain enthalpy than chlorine. This is because of the small size of fluorine. Because of its small size, there will be a relatively more electron repulsion between its electronic repulsions. And due to that, the electron gain enthalpy of fluorine is less negative than that of chlorine. And chlorine is the most negative electron gain enthalpy element. That is the element which has the lowest electron gain enthalpy because it has a negative charge. Actually, negative charge, so highest negatively charged electron gain enthalpy element. So first of all, across the period, the electron gain enthalpy is becoming more negative. Down the group, it is becoming less negative. Group 0, that is our noble gases, have their electron gain enthalpy as positive values. And half-filled and completely filled atoms like beryllium, magnesium, nitrogen, and phosphorus have close to 0 as their electron gain enthalpy because of their half-filled and the completely filled orbits. And what else? Fluorine and chlorine. Fluorine has a less negative electron gain enthalpy, and this is because of its small size, and there'll be electron repulsions. So because of that, there is this one unique difference in the halogens that we observe. I believe that's something we are observing. I think even that's why we have the same issue with oxygen and sulfur. So if you see 141 minus 200 and then you go down. But this difference is more remarked because of the fact that these are halogens and they generally have a tendency to accept an electron. With that, we complete the electron gain enthalpy. Electron gain enthalpy is basically the energy released when an electron is added. The negative sign in front of that value represents the fact that it's easier to add the electron and a lot of energy is getting released in the process. Um, for elements like alkaline metals and alkaline earth metals, they have relatively lower negative value of electron gain enthalpy. And as we go across the period, the electron gain enthalpy is becoming more negative. As we go down the group, the electron gain enthalpy will become less negative, and all of this is based on their size of the atom. With this, we complete electron gain enthalpy. In the next video, we will be discussing about the electronegativity.